Okay. Yeah, welcome. My name is Michael Behrisch, and I want to talk about transport simulation. So Move Your Crate was the title. And I'm not, let's say, into the IDE Eclipse business so much. So we are from the SUMO project, which is a development at the Institute of Transportation System at the German Aerospace Center, where we did for some time now transport simulation. And I just wanted to tell you today, so how could you use those tools for also simulating your own mobility, let's say. So everyone who has his laptop with him or her can just now pull it out, and we can try to stress the local Wi-Fi a little, and maybe try to do something together. If this does not work out, then I have everything prepared as slides as well. So I hope I made the code big enough so that you can now don't have to use the the keys to take the link from the slides. So everyone can, of course, we are here in an open source environment. So SUMO is an open source software. You can download it. We will have today scenario generation for traffic simulation with a few clicks. I will show something about optimizing everything, also your own mobility, but also, mobility in general for the scenarios. We'll talk about new modes of transport and connected mobility, and then finish with some outlook of where we are going inside Eclipse, the Open Mobility Working Group. Okay. So hopefully you can now download SUMO, while I'll just give the short introduction about what SUMO really is. So SUMO stands for Simulation of Urban Mobility, and is a microscopic traffic simulation software developed in C++. And for about 17 years now we are working on this, and the target is, let's say, to have a whole city, the traffic in a whole city, mainly road traffic, but also public transport, simulated for, let's say, a whole day or the peak hour on just your consumer hardware, let's say, and have this more or less in real time. So the movement of every vehicle. Current limitation is about the size of Berlin, so you cannot do the whole world, but it's, let's say, more than just your home village. And at least not for me, but my home village is Berlin, but you can do a city size. You have all the tools available which help you in setting up this. Most importantly, probably for most of you, is you can not only have your simulation in a closed box, but you have the API, the connectivity to all to couple your own applications to the simulation. Okay, what's also important here is that we are an open source project from the very start. So we had some time to build a community, and so we have a very active mailing list where you can ask questions and get a lot of answers, hopefully. Also, for, let's say, the size of the community or how it is distributed, we are a research organization, so it is mainly used for scientific purposes. So let's say the average user is some PhD or master student who's looking for a tool, finding it, asking questions, and on the mailing list to get his thesis ready, and then when it is ready, we never see him again. But nevertheless, there are contributions, and but we can, or it's easier to count downloads here in this case. And I just noted that for the last, in my feeling, 10 years, it was always the US which were in the top in the download statistics. But when I generated this slide some days ago, The first time it was India. Okay. So we are still on SourceForge with our downloads because we didn't quite finish all the IP process at Eclipse yet, and that's why we could not make an official Eclipse release yet. But yeah, SourceForge gives you this nice picture. Okay, so what can you do with SUMO? In principle, you can move or simulate the movement of any object in a city. Yeah, that sounds big. It's not quite true. I mean, we don't have the butterflies ready yet, but we are close. We simulate a lot, also traffic on the rivers, bicycles, pedestrians, also goods. We did even ships, although I have to admit that ships are more or less slow vehicles on blue roads in our simulation. But nevertheless, people sometimes only want to visualize some good transport over different modes of transport, and then it's a good idea to have something like also a ship or a truck ready, which can transfer goods, yeah, on a river. Okay, what can you do with it in general? So that's of course also true to every other traffic simulation package. You want to do traffic management, of course. That's why it was developed first. So you don't look into the individual vehicle because our modules are not detailed enough. But you look at the district, at the city as a whole, and want to know, if I change here something at the infrastructure, or if I change the way vehicles behave in general, how does this affect the traffic flow? The same is true for public transport, or if I have new technologies, how does this affect the traffic system? The problem is, it's a challenge as we rather put it, you need the travel demand from somewhere. So you need to know where people are originating from, where they want to go to, and how they choose their mode of transport, for instance. So this is an input. We don't put that much focus on generating data like this. We expect more or less the user to have it or to have some means to generate it. But if you have the travel demand, then it gets easier to have a realistic scenario. Of course, you can also do with random data. That's also the way we will follow today. So SUMO is not a web application, as you probably guessed from the few screenshots I already said, but we start with the web, just because it gives an easy interface and something for you to start now without, let's say, having to install too much. If you have SUMO on your device already, it is even possible on the Mac, then you can now select the Osm Web Wizard. I will show you here. And, okay. And it will fire up some web GUI, which just shows you the OpenStreetMap of the location you choose. We can even go here and say, oh, use the current location. And I have to tell the Firefox that I'm allowing it. And now here we are. Beautiful Ludwigsburg. And yeah, so we are currently somewhere here, I think. No, below? Yeah, here. Okay. So that's already 2 of the 3 clicks. So I have the third one, generating scenario. So what now happens in the background is it just downloads the OpenStreetMap data, and you would say, okay, so the network doesn't seem to be a problem. Well, that's only partly true. because OpenStreetMap is, of course, something where you have a map in the sense of you want to visualize geographic data. It's not necessarily has all the structural info you need for a traffic simulation, but it's a good starting point. And yeah, that was the simulation I prepared. That was not the one you downloaded. Yeah, here it is. Now you can already start. And you see things are moving. But you also see the junctions. While they are complex, they are not that complex. There are things which went wrong here. But nevertheless, you already have vehicles and you have a moving simulation. Okay, that was the very first start. So another thing you can do now from the web interface is just add public transport. Just tick one box. And maybe also we want not only cars, but bicycles and pedestrians as well. And maybe some more cars, because it looked a little bit not crowded enough, let's say. Okay? Doing this again. You see, yeah, he has to do the whole process of downloading the data again. That's why it takes some time. But what you can do then with the created scenario is just, have a look at the points where you're interested in and where you see the traffic does not work well. So, in short, first you need the demand for your scenario. So what we saw now is, you can generate random routes, and there are also more tools to give the traffic demand into your scenario. So if you have, for instance, traffic counts on single roads or induction loops, then there is a tool in SUMO which just generates you the SUMO routes for that. We call that the F-router for detector flow. Or if you have turning ratios on the single interjunctions, on the single intersections, then you just want to know how many cars are turning to the right and left, and of course you have a model, let's say, with which probability everyone turns, and can generate routes from that. And there are even small tools which generate you something like your virtual population. So having, let's say, at least the location of the schools and the living areas and the working places, you can somehow guess a part of the traffic by just saying, in the morning the people have to move from the living places to the working places. Another input we could handle is origin-destination matrices. So if you know so many people move from this district to the other, and do this, I don't know, every day in the morning between 7 and 8,000 people move from, I don't know, Ludwigsburg to Stuttgart maybe, then you can put the data in here and generate routes from that. Okay, so there is tooling, but you always need the input data, of course. Okay, so what are we doing now to try a little optimization of the transport? I just showed you, you can add public transport just from the web interface. I also checked bicycles and pedestrians, and hopefully it already started now. Oh. Okay. And if we start now, we might have at least bicycles, as far as I can see. So they are a little bit small. Maybe I make them bigger. So now all vehicles are a little bit bigger. But you also see it gets crowded. Yeah. So maybe we already added too much traffic in here. But there may be other problems too. I mean, if you want to optimize your mobility, you don't want things like that. You don't want junctions where you have more traffic lights than streets, let's say. So there is tooling around already in SUMO, which helps you here. But first, maybe we just focus on the obvious errors, which are when you are not with your car here, then you know that a lot of these paths you see here, which are already depicted in gray, are in fact not only for pedestrians but also for bicycles allowed, which is not correctly labeled in OpenStreetMap. So when you simulate here, you see only pedestrians, or in the simulation we have here, there are not pedestrians, that there are only pedestrians moving on this infrastructure. Can we see them? Also a little bit small. Okay. Maybe I just show my saved example here. So what can we do to adapt, let's say, to fix the problems on OpenStreetMap? Of course, you can always apply for your OpenStreetMap account and then fix the data there. And if all the paths are labeled correctly, then we can import them and have the bike path ready. But that's not the way we do this in general, because this is a long process, and we get not the fix as fast as we probably want to. So what we can do is just edit our network. So what I did here, so SUMO has a tool which is called NetEdit, which just opens up your network, and you can now, change everything you want to. Let's say we know that this street here, I think it's the Karlstraße, where I came here in the morning, is open for bikes. Then we can just select it and say, well, then open it for bikes. And then, it will simply do. And you will see that if you start the simulation again, that we have now a bike path here ready. Okay, I also added here the opposite direction, that the bikes can do and go in both directions. And it takes a little, but there they are. Okay, so you can modify your network to your needs. You can show which ways you need to adapt. And the problem is now when you try to scale. I mean, what SUMO can do here in this simulation is you can try to even add more traffic. There's an easy button, just says scale traffic. And if I go to factor 5, let's say, then you will easily see that it starts to pile up, and you will see no one is able to move. And what you then do usually is just optimize your local intersections, for instance. So the places where there are traffic lights should not look like this. It is also a task here for NetEdit, where you just have a look at those intersections and say, yeah, probably this should not be 5 of 6 intersections, but just 1. So let's just join them. Oh, no, he joined them with the ones I selected earlier. And if you do this, SUMO is also able to recalculate the traffic light programs and give you a new network where, you know, everything, not everything, but at least everything on the big arteria where you join the junctions and modify the traffic lights is working better. Okay, so we need to scale up again. And we see that still it will be able to handle larger amounts of traffic on the bigger junctions here, although they're really complex also with this bike traffic coming through and things like that. Okay, so that was part 1, optimizing with traffic lights. So this is something which is important for all the people who already have networks which are not, let's say, in OpenStreetMap, that you can do more than just using the one or two clicks from OpenStreetMap. You can just use OpenDrive data, for instance, shape files, a lot of other geoformats, or you can do a handcrafted SUMO XML to import your own network. And what the NetConvert tool, which is part of the SUMO suite, also does for you is create traffic lights, create junction priorities, and close your application. No. And do public transport generation. Okay. Yeah. So this is what we did now. What is also possible now is, if you have your traffic light, you probably see that the phases, so the amount of green time the single streams get is not optimal, and you want to modify it. And of course, you do not want to modify this by hand, although it's possible if you have only 1 or 2 junctions. There's also tooling to automate this. No AI tools at first, so just simple calculations. What is the amount of traffic? How long should the green time be? But last year at the SUMO conference, there was also a presentation from someone who did this really with deep reinforcement learning. And of course, they benefit from the fact that they have all the open tooling available in SUMO and can really do a whole optimization loop with the simulation inside. Because you can also run this simulation without the graphical user interface and get really fast results for a lot of simulations. Okay, we are doing this traffic light optimization also in projects where we really bring it to the street. So where we can incorporate new sensor data first in the simulation, and then simulate how the traffic light will behave, or how a new algorithm will behave, and then bring it to the streets afterwards. For instance, we did this year in Halle and in Brunswick. And what I find interesting here is that you can also bring the simulation itself to the controller. So if you look at the boxes which are on the side of the street, and yeah, if there's a DLR sign on it, it may be the case that our simulation is in fact running inside the traffic light controller just to complete the picture which the sensors give, so that you can handle the sensor data and enrich it somehow with the data the simulation gives, to give the traffic light control algorithm a more complete picture of the traffic situation. Okay, next point. Automating vehicles. That's always a nice one for simulation people, because for simulation people, vehicle automation is probably the easiest thing to do. Because, in fact, what we are doing here is building vehicle controllers. Very easy ones, very simple ones. But in fact, most of our vehicles are closer to what an automated vehicle does than what a human does. So if you ask us, yeah, can you simulate an automated vehicle? Most of the time we say, yeah. What do you want? I mean, it is automated. It is, you should rather ask, can you simulate the human? And this is really the point here. Where do they differ from each other? So one point, which is the easiest one to show, is just reduce the gaps. So if you have two automated vehicles, you could assume, and they are communicating with each other, so you have automated and connected vehicles, you could assume that they are able to drive at closer distance. Okay, let's say it would solve one problem in the sense of that the capacity of our motorways could increase drastically if all the people or all the cars would only keep a time gap of, let's say, half a second to each other, instead of the 2 seconds you are currently required by law. Yeah, so this is this formula of halber Tachostand, as you call it in Germany. So this amounts to about 2 seconds. If you could reduce this, the capacity would increase. And yeah, that's easily shown by simulation, where just by changing one number, which essentially says how large is the time gap. Okay, but to have it more difficult, it is really hard to answer the question which assumptions are true for the human and which are true for the automation. So if you make the automation really on the very safe side, let's say, so everyone has to adhere, for instance, to the 2 seconds rule, then the traffic will simply collapse. So it will. You can show in the simulation that if you build your motorway such that everyone adheres to the rule, and you try to put the amount of traffic which you can measure outside on there, then it will not work. So this is rather a question on how you set up your simulation than what can really be done. Yeah. So what we currently do in the field of of automation is, for instance, the project Trans8, which looks at the interface, let's say, where you do a transfer from automated to manual driving and back, and what happens in these regimes where it is not clear who is doing what and which how do the other cars in the surrounding area react. So, for instance, if you have this shock waves resulting from manual driving when all the vehicles react to each other, can those be mitigated just by inserting an automatic cruise control here? Okay. Another example, yeah, maybe I just skip now the simulation, the live simulation, and just show the slide. Is automated vehicles in the sense of public transport. So what we call demand responsive transport. That's also a big topic when it comes to simulation, because you don't have all these systems outside there yet. So you really want to know if you have a city like Stuttgart, can you replace a major part of the car mobility with a system of completely shared vehicles? So of course, so the topic is always how do they schedule, and do they take more space on the street than because they also drive empty routes, for instance, and they are and sharing is not always perfect. So maybe there are a lot of more cars on the street than before. Does this work? And this is also a question you can answer with a simulation. And you can do this fast by showing, by starting with a very simple approach. What happens if everyone has a vehicle at their disposal and at the very point where they want to start? So that's easy done with a simulation. And then you can always route empty vehicles to the next location. And does this help? Does this improve mobility? Okay. So that was my examples, and then now I just want to give some ideas on how we built this, and yeah, maybe how you as developers or technical interested people could build upon it. So we are building with C++ and have an, let's say, quite old-fashioned stack. So this project is also some years old. But it is completely open source, so also the tools we use, everything should be open source and should be cross-platform usable. So that's why we are using mostly C++ and Python stuff. And the Fox toolkit probably nobody has ever heard of. It's just a GUI toolkit we use because when we started, Qt had not a commercially friendly license. So the open source version of Qt could not be used for commercial projects without paying something. That's why we needed a different GUI toolkit. And some words for the so-called traffic control interface, which is the, let's say, the online interface of Sumo, where you can really access every object in the simulation and not only read data, but also modify how the vehicles behave, how the people behave, how the traffic lights change, and whatever you need with the client language of your choice here, as, at least for the four ones you mentioned, Python, C++, Java, MATLAB. There are also a C# client is in the making as far as I know. And then you really can control your whole city as far as mobility is concerned in the simulation. Okay, there's more to come. We have lane-free traffic and intermodal traffic, so people changing from train to car and to bike and back again, parking models, and of course it's always testing, bug fixing and improving. And there is the Open Mobility Working Group, which is starting at the beginning of next year, where we want to bring together, let's say, at least some of the big names. So we have just now all the working, or all the Eclipse members which are somehow in working groups, so those won't not be all in the Open Mobility Working Group, but which will be, let's say, a new way of incorporating all of you and all of industry as well as developers to work together on the future of this project. Okay, we had 1.0 1 month ago and had done 1.01 in 1 week later. So this is the current version you can download. And of course, all of you are invited to come to our SUMO conference, which is in May in Berlin. And yeah, hope to see you there. Thank you.